Okay, so today we're going to be doing average value. Now, it's saying by understanding the fundamental theorem of calculus, which incorporates an understanding of integrals. This is not an average rate of change. When you're asked about a average rate of change, then that means that we have to do the difference quotient, and it refers back to limits and derivatives in those lessons, okay? So when you're asked for the average value, it's just a particular number, and it involves integration now. So f has to be on a closed interval from a to b, and the average value is found by using this formula here. Okay, so please make sure that you write it down, and let's do an example. Okay, I seem to have lost the slide with the example, but that's okay. So, example. Find the average value, average value of f of x, which f of x is defined as 4 minus x squared, on the closed interval from 0 to 3. And it asks you to answer this question. Does f actually take on this value at some point in the given interval? Okay, so we're going to talk about that question. So let's get to our formula that we need to use and apply it to our example. So we're asked about the average value of our function 4 minus x squared. So if you'd like to declare what that function actually is, we put in the parentheses. AV stands for average, or average value. And it's just 1 over b minus a. So we do need that closed interval in the exact values, like 3 and 0. Okay. And we're going to integrate, of course I ran out of space, from a to b for our function 4 minus x squared. Please remember to write the x. It reads as respect to x. So now, let's actually start calculating a little bit of this. So 1 over 3 minus 0 is 1/3. Done. Now we haven't gone into the rules for our integration just yet. But we did discuss how to do FTC Part 2. So in FTC Part 2, we established what capital F of x was. And in this particular case, when we see a constant 4, the first part of f of x must be 4x, because if we take the derivative of 4x, we get 4 minus, I'm just kind of copying it, x squared. So we know that x cubed gives us 3x squared as far as its derivative, okay? But we don't want 3x squared, we just want x squared. So we have to third our 3x squared, okay, in order to do that, or get x squared. So if that's the case, we need the 1/3 x cubed, okay? Again, now take a look at what we just wrote for f of x. If you take its derivative, okay, we would get 4 minus, it would be x squared. So at this point, since I'm writing an antiderivative, that would be fine, but the general antiderivative is the plus c. When we go to evaluate our definite integral using FTC Part 2, then I don't need the plus c part. I do, however, need to plug in the upper limit of integration in for x and the lower limit of integration in for x. So I'm leaving parentheses where I need them. That's a 3. And just about squeezing it in there. Okay, so my upper limit was 3 and my lower limit was 0. Okay, and then we calculate. So the 1/3 is still on the outside. I had green before to indicate the parentheses. Now on the inside, we have 12 minus 1/3 of 27, so that's actually just 9. So 12 minus 9 is 3. And we're subtracting 0, so this is just 3. So 1/3 of 3. Don't forget that you have to calculate the 0 part. But because that's just 0, I don't have to write it, and I can eliminate that parentheses all the way at the end here. My final answer for the average value, and I kind of like got lost along the way here. We went from here to here to here. We're getting 1/3 of 3, which is 1. Okay? So that's the answer for the first part. We found the average value of f of x on our closed interval from 0 to 3. So the next part, we end up needing to answer this question. Does f actually take on this value at some point in the given interval? So, does f, let's review where f is. Okay, and I don't think I need this slide here, so I'm going to use this space, okay, to, well, give me space. Ta-da! F was 4 minus x squared. We want to know if this average value, which is our y, will take on some point in the interval, okay? So I'm going to take my answer and set it equal to my function and solve. So if I go to solve this, then I get into an issue here, just a tiny bit of one. Don't forget the plus or minus when you go to solve. This one is rejected because it's not in the domain, not much of an issue. But this is what we're going to look at. X equals the positive radical 3. So my answer here for this question is yes. The function assumes its average value in the given interval. I'm going to run out of space. I'm going to come over here where my question is. In the given interval, and this is when x is equal to radical 3. Okay, so this is great. So we know when that is going to happen. We can take a look at this graphically with the graphing calculator in class if you need more of a visual on this. And in the meantime, let me know if you have any questions on the calculations. Good luck.